Okay, let's talk about mixtures today. It's good to see you again. And we're going to talk about when things are more than one thing is put together into a mixture. So panning for gold is an example of trying to separate a mixture when you have gold, flakes, and gravel and water, and you're trying to just separate and get the gold. So we use physical properties, different properties of elements and compounds to use that to separate them because every different element and every different compound has different physical and chemical properties. So we can use that to separate things. So how can we classify mixtures? There's a way that we can figure out what a mixture, like what category we're going to call it. And so just let's define mixture. A mixture is a physical blend of two or more components. So it can be, these components can be elements or they can be compounds. So salad bar is an example where you have a lot of different things that you throw together into your salad. And each salad has a different composition because some people like cheese, some people like cucumbers, some people like radishes. You know, it just depends on your taste. So every salad is going to be unique for the person who makes it. Same thing with a mixture. We can vary the different components of a mixture depending on what we need in chemistry. So we can either have a mixture that's called heterogeneous or homogeneous. So homo means the same and hetero means different. So we're going to use those words to figure out what mixtures are, how we can classify them. So when you have a mixture that's not uniform, when you can see like different little speckles or different colors, little points of different color, that's called heterogeneous. So like if you mix salt and pepper together, that would be heterogeneous. Because you see the little pepper pieces mixed in with the white salt parts, and so there would be differences, so it's heterogeneous. When everything looks the same top to bottom, side to side in a container of a homogeneous mixture, then it's all the same, and so it's called homogeneous. And another name for something that's all the same throughout, it's perfectly uniform, the same, it's called a solution. So you might think of an example in real life. So Kool-Aid is a good example of a solution, because if you have some in your glass that looks the same color and everything top to bottom, side to side, but there's a lot of things in there. There's sugar, there's food coloring, and then there's water. So that's a solution. And we could add more water to the Kool-Aid or less water to the Kool-Aid, but it would still be a mixture. It would still be homogeneous because it looks the same, and it's called a solution. That's a special name for homogeneous. If we can see differences in the composition of something, we're going to have something called phases. So you already know this in real life. If you put oil with water and you shake it up, but then you let it set for a little while, then you're going to see oil floating on top of the water. So you're going to have two phases. You'll have the oil phase and you'll have the water phase. So if you have something homogeneous like the Kool-Aid, it has one single phase. It's just liquid all the way throughout and it looks the same. If you have grape Kool-Aid, then it's going to be purple, top to bottom, side to side, all the same color. If you have heterogeneous, you can have two or more phases. Like if you decide to put rocks with water, the rocks aren't going to dissolve in the water, and it's still a mixture, and it looks different because you can see the rocks and you can compare that to the water, so that's heterogeneous mixture. So if we put oil and vinegar together for salad dressing, we shake it up and then we let it set, the oil is going to float on top of the water. So those are two phases right there. You have the oil phase on top, floating on top because it's less dense, and you have the vinegar watery phase down here. So you have two phases in this picture. So if you ever go ATVing, maybe you like that, you can see signs like this that, hey, we can allow ATVs in this area. And those are put up with aluminum nails instead of iron nails. because we're outside. So let's talk about why that matters. So here's the properties of aluminum compared to iron. There's some things that are the same and there's some things that are different. So they're both metals, they're both gray color, and they both do not dissolve in water, but one's attracted to magnets and one is not attracted to magnets. So being able to see the properties of the two things we're trying to separate and seeing something that's different will help us separate those two things out of a mixture. And chemists do that a lot. They take mixtures and have to separate things. So if you're going to figure out how to solve this, you're going to look at all the properties, and then you're going to see that iron and aluminum don't share that magnetic property, and we can use that information. So we could use a magnet to separate. If we had a bunch of iron nails mixed with aluminum nails, then we could use a magnet to just get the iron attracted to the magnet and keep the aluminum by themselves. So that's the way chemists use properties of matter to separate things, and we do that a lot. So how can we separate these mixtures? We talked about a little bit already. So we're going to use differences in physical properties to separate mixtures, because we saw that metals have different magnetic properties, and we are going to use that physical property to separate them. That's one example. Another thing we can do is use something called filtration. So we'll use that in the laboratory a lot. We're going to have things where we have a solid and a liquid mixed together, and we need to separate the solid from the liquid. And we can use that in a process called filtration. So you see this in when you make coffee. You have a coffee filter, and you put the coffee grounds in the top of the coffee maker, and then you let water pour through it. Well, the filter keeps the solid coffee grounds away from the coffee that you want to drink. So that's called filtration. So we could do this when we make pasta. We have the pasta in the water, we boil it away, and then when we want to separate them, we use a colander, which is a type of filtration. Another thing we can do is when we have a mixture of two liquids together, sometimes one will boil away at a higher temperature and one will boil away at a lower temperature. And we can use this thing called a distillation apparatus. That word right there, distillation. This whole setup is a distillation apparatus. We boil the mixture together, and then the one that will boil at a lower temperature will turn into steam first, and then we can put it through this thing, let cold water touch that vapor, and then it turns back into a liquid again, and then you can grab it. And then we'll have, over here we'll have the one component, and over here we'll have the second component. So we can separate two liquids that way by distillation. So let's see how much you remember for this. So let's do our quiz together. Good luck. So look at the question. Which of the following phrases describes a mixture? So what is a mixture? So let's see what you thought. See if you got it right. So composition can vary, because like the salads, we can have different things that we like in our salad. So which one of these is homogeneous? Remember, homo means the same. So what looks the same, top to bottom, side to side? What do you think? Alright, let's see what it is. So vinegar looks the same, top to bottom, side to side. It just looks like water. So that's homogeneous. Okay, last question. How are we going to separate homogeneous mixtures? Things that look the same, top to bottom, side to side. That's one of the things we talked about. Let's see what you remember. So it's distillation. That's how we can get two liquids to separate from each other. So I hope you learned a little bit about physical properties and about mixtures. Okay, I'll talk to you soon. Bye-bye.